Question 8, carefully and accurately graph the following three relationships. I do appreciate that on the test, many of you attempt to use like the edge of a maybe an index card or the edge of your calculator to draw straight lines. Normally, I would be distributing calculators and or not calculators, rulers, and you could make really great straight lines, it turns out. But in terms of disinfecting rulers and stuff, I'm glad that you're using alternate methods. So this first, for part A, right, this is a fairly straightforward equation because it is given to us in slope-intercept form. But let's say for a minute you panic and you have no idea what that even means. One of the things that's nice to do is you could go to a different representation, right? Instead of thinking about it as in slope-intercept form, maybe you forgot what that is, you could just look at a table of values. So for example, I could say, well, if x is 0, right? So x's are those things that I'm going to plug into this variable right here. If I plug 0 into that, this whole first term becomes negative 2x times 0, or negative 2 times 0, which is 0. So I get an output of 7. So when x is 0, y is 7. When x is positive 1, again, I'm putting the positive 1 in for x, this becomes a negative 2, and negative 2 plus 7 becomes 5. And I'll put in one more. If I place the number 2 in there, this becomes 2 times negative 2 times 2, which is negative 4, and negative 4 plus 7 is just 3, right? So if I plot those points, you can see here's the point x is 0, y is 7. Here's the point x is 1, y is 5. And finally, here's the point x is 2, y is 3. Now, I want to point out what's happening here, right? You can see now looking at this in terms of slope-intercept form, 7 was indeed my y-intercept. So when x is 0, you can see I'm going through that point perfectly. And then you can also see evidence of the slope pattern, right? The slope pattern for this line is negative 2. That means I'm going down 2 units over 1, down 2 units over 1. So you can see just from looking at that equation y equals negative 2x plus 7 exactly what it's going to look like. You can see the y-intercept and you can see the slope pattern. If I take the ruler and line it up here, about there, and then let me go ahead and grab, that's not good, grab this pin and I will just draw a line through that. So there we go. That's the first relationship we were asked to graph, and I'll label it A. The next one, it says graph the function x equals 9. So looking at this, so x is equal to 9. Looking at this, we can see, well, clearly this is a spot where x equals 9. And it's also true that y is 0 at that point. So if we start thinking, okay, that's where x is 9, but actually there's other points where x is 9. In fact, right here, this is a spot where x is 9 and y is 6, or x is 9 and y is 2, or x is 9 and y is negative 3. It turns out all those points, right, for every single one of those points, x is equal to 9. Well, the graph of that line is just the collection, all the points where that's true, where x's are all 9. So if I line my ruler up there, I can graph this line. This is the line, x is equal to 9. So this is my response for answer B. And then the final equation I have was not written in slope-intercept form. You can see that it is, actually this is, I guess this is this is standard form, but I can transform it into slope-intercept form so that I could do the same thing with the table of values, or I could just recognize the y-intercept and the slope and use those. So to do that, I'm going to subtract 4x's from each side. When I take away 4x from the left-hand side, this becomes 2y. And then when I take away 4x's from the right-hand side, I get negative 4x and plus 8. So you can see on the left and the right-hand side, both, I've subtracted 4x's. Okay, now to get y alone, I'm going to divide every single term by the number 2. When I divide the first term by 2, I get y, When I divide the second term by 2, I get negative 2x. And when I divide the third term by 2, I get plus 4. So this is the multiplication property of equality if you want, or the division property of equality. You can either multiply every single term by a half or divide every single term by 2, and you get this equation. All three of these equations are equivalent equations. If I was to graph the first one, or the second one, or the third one in Desmos or GeoGebra, they would all look exactly the same. For me, visually, this is nice to look at in this form because I can see both of my parameters. I can clearly see my slope parameter m, so I know that the slope is negative 2, and I can also see my y-intercept parameter b. Because those are so visible, right, I can just come back up here and graph this. So I will place a dot at 4, and then from there I'm just going to go down to and over 1 unit, down to over 1 unit. So what I notice is that this line and the line I did in part A both have a slope of negative 2. They both have the down 2 over 1 pattern. What's different about them is they have different y-intercepts. So these two lines are parallel to each other, and they won't intersect, at least not on a Cartesian coordinate plane. So A, B, and this is point C. So there we are. We have all three lines that are graphed, and I hope that you have some ideas of things you might try with multiple representations if you get stuck and you're asked to do these things again.